Hello, Pratham. Am I audible to you?
Hello. Hello.
Yeah. Hello. Let me know if I'm audible to you.
Hello, sir.
Hello. 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 Yeah. Is
Yeah,
it audible or
can you
not?
hear me?
Hello, Pratham. Is it audible or not? Hello. Is it audible, Pratham?
Give me a second.
Not sure whether I can hear you can hear me or not.
Hello.
Yeah. Hello. Am I audible?
Yes, sir. Yes, sir, my boss.
But okay, I can hear you.
Is my
Uh,
voice clear?
your voice is a bit low. Hello.
Yes, sir. Can you hear me now?
Yeah. 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 Now it's fine. Now it's fine. Okay. My voice, my from it is clear from my side, right?
Yes, sir. Totally.
Okay. Yeah. All right. So yesterday we did. Yeah, we ended up with the this push. Yeah, okay, it is there. Yeah, so we completed the basics. We discussed electric charge. Yeah, type of charges, some properties, right?
Yes, sir.
Internal properties also, charging of a body, methods of charging of a body, and three methods were there: conduction,
Yes,
induction, the frictional one. Uh, you can remember this part also, the work function. It is important.
yes, sir.
Okay, so these things were there. We discussed in the last class. So today we'll be starting with your Coulomb's law. Okay? So we'll be starting with the Coulomb's law.
Yes, sir.
Coulomb's law. Okay. So what this law says, okay, yeah. So it is similar to your gravitational force. Okay, the law of gravitation. What that law says, two bodies are there. There will be a force of there will be a force in between them, right? Force of
Mm.
attraction between them. If two bodies are. This is the one of the explanation of the gravitational force, law of gravitation. Okay. So here, what Coulomb's law says that the force of again it is very similar to that. The force of yeah, the force of we'll not use attraction or repulsion. We'll say just interaction. Okay. The force of interaction between two charges. Okay, two charges is proportional to proportional to what? The product of charges and inversely proportional to inversely proportional to distance between them. Okay, not distance, the square of distance between them. Okay, between, right. So this is what the Coulomb's law says. Okay, fine. If I have to put this into a mathematical equation, what I'm going to do is, let's go with the definition. What definition says? I have two particles. I don't know which kind of those particles are, so I'll just take them as Q1. I'll say another one is Q2. Understood?
Yes,
There's
sir.
a force of interaction. Okay. So particles are there. Let's say this is the force of interaction. Again, I don't know whether it is a force of attraction, repulsion, what kind of. I'm just interested to find out the force, the value, okay, the magnitude. So I know the force is strictly proportional to what? The product of them. Okay, this is I know. It is also inversely proportional to distance between. Let's say that the distances are. One more thing, even if you see it is a circle, take the distance from the center. Okay, don't take from the edge, from it is
Yes,
connecting.
sir.
Okay, take it from the center because look, there's no force it is because if I'm taking any particle now, the net force is on the center of mass. Okay, you know the center of mass thing, right? So center will
Mm.
be the point where the center of mass will be there for a smaller bodies. Okay, so the distance you have to take from the center. So yeah, this will be your thing. Okay, these two things are there. We can combine them as F directly proportional to Q1 by Q2, and we can rewrite this. All right, you know, I have to remove this proportionality. So where I will go, I'll put this equal to and put a constant. Okay.
Yes.
So what is this constant? The value of this constant is 1 by 4 pi epsilon. Understood?
Yes, sir.
Okay. So this is one thing. This is a for now, like the thing which we are doing right now. This is in vacuum, you can say, or free space. For the sake, you can say as free space. So we can say constant of a free space. All right. Now, if you see, there's one more term, this epsilon naught, right?
Yes,
So
sir.
what is this epsilon naught? This epsilon naught is nothing but permittivity,
Hmm.
permittivity of free space. Understood? What is it?
Yes, sir.
It's an another constant. The value of, like, the name of it is permittivity of the free space. Okay. All right. Yeah. So can you figure out the unit of this k?
Coulomb.
Yeah. Like, I just want you to figure out the unit of this k. SI unit of this k. This constant. What is the SI unit of this constant?
Acha. Wait. Newton meter square by c square. Coulomb square.
Newton meter square by
Coulomb square.
absolutely the same. Okay. So it is what? Your Newton meter square per centimeter. Can I write this?
Yes.
Okay. So this is the thing. All right. So can you figure out for the epsilon naught?
Or the epsilon naught.
Yeah.
It should be the same but inverse.
Yeah. So we can write it like this. So, C. Okay.
So your screen is frozen and I can't even hear you.
Hello, Pratham. Is it audible or not?
So your voice is lagging.
Yeah, I know. I know.
No, I can't hear you now.
It's your network lag. Okay, myself. Yeah, you can't even like this. I think the Wi-Fi then.
Yes, sir.
Yeah. Audible clearly, right?
Yes, sir.
Okay. Yeah. So, yeah. So what is the value of this K? Any idea?
It is 9 into 10 raised to power 9. Uh, what is happening? Yes, sir, I can see you now. And even hear you.
Yeah. Okay. Yeah, Pratham, I was saying, what can be the value of this k? What is the value of this constant?
Yes, I was
Any
saying
idea?
it was 9 into 10 raised to power 9.
I'll just put my camera off. That will be better option. Yeah, okay.
Hello.
Hello. Yeah, I'm saying is, what can be the value of this free space? Any idea?
Yes, sir, it is 9 into 10 raised to power 9.
नहीं, वो आवाज उठ रही है। समझ आ रहा है।
So can you hear me now?
Okay, yeah, that's why. If my yeah, I can hear you. Am I audible to you?
Yes, the voice is clear now. It is
Okay,
9 into 10 raised to power 9.
yeah, 9 into 10 to the power 9. Okay, so this is the value. What about this
So I can't see the
magnitude?
screen.
Okay, I have shared my
Yeah.
screen, right?
No,
Okay,
no, sir.
okay. Okay. I think it got disconnected. Can you see her now? Oh, can you see
Yes.
now? Okay.
Yes, sir.
Yeah. So what is the value of this E naught epsilon naught?
Uh, I don't remember it.
Okay, don't worry. So it is basically your 8.85 into 10 to the power minus 12. Okay.
Okay.
Yeah, it is minus 12. Okay, and the unit you already told. We can put that unit over here. Yeah. So we can put the unit. What is the unit? The same. Okay,
Infinity
always start from
Newton.
the look when you are writing the unit. Now always start the first the thing which is in positive power, right? You can
Yes,
see
sir.
earlier we had n m square something, so we'll put c square first, then your n minus 1 and m minus 2. Even if you do this,
Okay.
no problem, but prefer the one having a bigger power. Okay,
Okay,
so
sir.
basically put the positive power and then negative power. Okay, that's it. This is what you
Yes,
can do.
sir.
Yeah. So look, till now what we have discussed is a vector form, like it's a normal form of your Coulomb's law, right?
Yes, sir.
It's a very normal. One more thing, if you see this epsilon naught, what is this? This is for the free space, right?
Yes, sir.
If you are in some medium, for medium, we will call it as EM. Okay.
Hmm.
What is it? Permittivity of a medium. Now this comes as permittivity of medium. Okay. Even better if you call it as electrical permittivity, not just permittivity, electrical permittivity.
Okay, sir.
One more. So electrical permittivity of a medium. This is what we know. Also, okay. Um, just a task for you. Let's say you have two charges, okay, and there's a force between them. Let's say F. Then what I did, I put both of the charges into the water. Into the water. So what do you think? Okay, now if I ask you what is the let's say let's calculate force in both condition. So if you see one is F1, right? Let's say I'm saying F1 is for the outside, or let's keep it as F naught. What is
Okay.
this? K Q1 Q2 divided by the R square, right?
That's good.
You can see the charge is same here and the distance is same.
Yes.
Charge is same, distance is same. Okay, yeah,
Yes.
distance is same. In the next case, it is FM, in basically the medium. Okay, don't think it
Yes.
is water; it is some other medium. K Q1 Q2 divided by R square, and you can write it as Km. Okay, for some medium. If you see carefully, in both conditions, only one thing is variable. This parameter, right? The only parameter
Yes.
which is changing, and I'm getting my different answer. So if I divide it, what I'm going to get, I'll be getting like F naught by F equals to K by Km, right?
Yes, sir.
Okay, fine. You know what is the value of k?
Yes. 9
Okay,
into
let's
10 is to
expand
power
this.
9.
No, no. Look, I don't know what is the value of km, right? So instead of putting the value, I'll put the
Acha.
formula for this, right? What is the formula for
Okay.
this? 1 by 4 pi epsilon naught, 1 by 4 pi em, right? This is what the value is. So the equation which we are going to get is F naught by Fm equals to epsilon naught m divided by epsilon naught epsilon. Is it clear?
Yes, sir.
Like how we put basically this is in denominator and it has epsilon naught, so it will go up the numerator, and the same it will happen with this thing is numerator. Okay, it will go inverse of the numerator, mean to say denominator. Understood?
Yes, sir.
Okay. Now, okay, just tell me, by seeing the force will more in case of what I can say, pure, yeah, force will more in free space or force will more in the medium.
Uh, I think it should be more in the medium. I think.
It should more in the medium, right? Okay, I'm just giving another example. Mm, you are okay, where you are free to move in water or in free space.
Free space.
Free space. Okay. Another thing is, what about the speed of light? Is it more in free space or in medium?
Free space.
Free space, right? So can I say like all these parameters are somehow related to speed, right? So can I say the force in vacuum or air is more as compared to force in medium,
Yes, sir.
right? So I can say this whole thing comes out some k, which is greater than one. Is it fine?
Yes, sir.
Can I say? So can I say that E of m is nothing but k times of m, k times of epsilon naught,
Mm, yes, sir.
right? Okay, what is this k? This k is not equals to actually this k. Okay,
Uh, yes, sir.
understood. Okay,
Yes,
let's
sir.
not put this k, right? It will become a problem for us. Let's not write the k. Instead, we will take it as er. Okay, er. We will call it as e of r as a constant, and here it will be your em equals to er times of e naught. What is this? This is nothing but dielectric constant.
Yes.
Okay, dielectric constant. Look, in some books you will find that dielectric it is written as k. But why we are not writing k? Because you have already another constant which we are denoting with k, right? So again
Yes,
putting it
sir.
this, it will become an arbitrary thing, right?
Yes.
Same thing. So we are using er. Okay. So this is the formula. Basically, you can see my force is inversely over. If you see, my force is inverse of your epsilon at, right? If
Yes,
all
sir.
parameters remain same, and you can see my epsilon naught is directly proportional to dielectric. Dielectric, you can say something restriction. Okay, it's a restriction. So more the dielectric, more the restriction you have. Okay, more the restriction, more your epsilon naught value. More epsilon naught, lesser the force. Understood?
Yes, sir.
So can we just replace it? Okay, yeah, that's fine. If you write k, can I say k naught is equals to e of r into k of m?
Uh,
Okay, just a
K not
second.
the K.
Why I'm saying, let's see. You know k is inversely proportional to e.
Yes.
So can I say e is inversely proportional to k also?
Yes.
Okay. Em is also inversely proportional to km,
Yes.
right? If you remove this proportion, some other constant will come. So what we can do, I can divide it, right? If I divide it, what I'm going to get? This km by k. Is it what I'm going to get?
Yes, sir.
We already know what is the value of this part.
Yes,
1
sir.
by er, or just 1 by e of r, right? So what I got, km equals to epsilon naught times of r into k.
Yes, sir.
Is it what I'm going to get?
Yes.
Check it again.
ER into KM is equal to K.
Check this part again. I think you're not
ER
fulfilled.
ER into KM is equal to K, na?
er into, no, okay, look, check this now. It is km, right? So isn't it should be k equals to er into km.
Yeah, that's what I'm saying. ER into KM is equal to K.
Okay, okay, understood. Okay, fine. So this thing can be removed. Okay, this is incorrect actually.
Mm.
Yeah. So let's put M over here, and this is what your equation is. So yeah, this is the some relation between your dielectric constant and your another constant. In there's a relation between this is the relation between your permittivity and dielectric. Okay. We can use it someplace. We'll be using it in capacitor too much, not here. Okay, so that's the thing.
Mm.
Yeah. Any
Okay.
doubt till now?
No, sir.
For sake of understanding, I can say for a vacuum, although it will be given, you have to take a dielectric as one. In air generally, it is again one. Okay, most of the cases one. Everywhere you have to one until it is given.
Okay.
For water, it is 81. Okay, and there are
Okay.
too many metals like different values. Yeah, for conductor, you can also say just in conductor what it can be. It is infinity. Understood?
Yes, sir.
All right.
Hmm.
Okay, fine. Yeah, this thing is clear. All right. So let's move to some other properties we have to discuss about. Okay. Yeah, one more thing I can directly write over here is Fm is one thing I left. Fm is also inversely proportional to ER. So ER you can also write it as F equals to F dash equals to F of F naught of ER. Okay.
Dash is equal to.
One
How
more
did
thing.
you?
Yeah. Okay. I'll just explain. We have already discussed this part. Just remove it. Let's go back. Can you figure out this equation?
Huh. Acha.
Right?
Okay. Yes.
Okay. So from here we have got that equation directly. So I'll just put a mark. Like Fm is equals to F naught by R. Look,
Ha ha.
you know this is the parameter who is dividing my the real force, right? F naught is a force when you are in the vacuum or air, right? So
Yes.
if you put the same situation in that medium, you just have to divide the value which you have got earlier by the dielectric of that medium. That's it. Okay. You don't
Okay.
have to recalculate the thing. Just divide by the dielectric.
Okay.
Is it clear?
Yes, sir.
Okay. So we can I say that dielectric constant of a medium is nothing but the ratio of force between two charges when they are placed in a vacuum to when they are placed in a medium. Clear?
Okay. Yes, sir.
Okay. Basically, you can make the definition also. If you know the formula or you forget, you can make the definition, right? The
Hmm.
dielectric constant of a medium can be defined as the ratio of force between particle when in vacuum to the ratio of particle when in medium placed at the same separation. Okay, this is what it
Okay,
can
sir.
be. So I'll just here it is to F naught. Things are same, just different methodology has been followed. All right. One more thing, Coulomb's law is not valid for distances less than 10 to the power minus 15. In case of R less than 10 to the power minus 15 meter. You know why? Because after this you have already reached till the atomic structure. Atoms, neutrons, protons are there. Okay, there this law will not directly it won't be valid. Okay, you have too many
Yes.
nuclear forces inside.
Okay.
Okay, nuclear forces are there, so they will overcome these kind of forces. That's the thing. So this is the thing you have to note down that it is not valid when you are very inside, for R is less than this. Okay. Also, yeah, what do you think? Which one is greater? Which force is greater? Electrostatic force or gravitational force?
Um, I read it somewhere electrostatic force is greater than
Yeah,
gravitational.
electrostatic is greater, right? When compared to gravitation. Basically, your electrostatic comes under the strong forces. Okay,
Yes.
you can think of it by using another idea that what is G? G. Yeah. What is that F? F is nothing but G M1 M2 divided by R square. What is this
Yes,
constant
sir.
value? 6.6 into 10 to the power minus 11. The negative factor, right? Here you
Yes.
have force equals to K, another constant Q1 Q1. But here, what is the value of this K? 9 into 10,
9
9
to.
10 to the power 9, right? You can see
Yes.
for a, okay, if you have to take this value as 1, you need this factor equals to 10 to the power 11. Then you can only nullify and get this value. But here,
Yes.
here even if this value, even if this value comes out to be 10 to the power minus 19, still you are going to get 9, right?
Yes.
So that's why we can say that electrostatic force is very, very, like, too much greater when you compare it with the gravitational forces.
Yes, sir.
Okay. All right. Okay. So yeah, some points which I want to explain. Like, I don't think I should write. Okay, let's write. Coulomb's law. Okay. Coulomb's law is valid for point particles only. For point charges. Okay.
Okay.
If you are applying it for some bigger charges, somehow you have to figure out the net charge at the center, then you can assume it to be a bigger charge. Because look, if bigger charge is there, right, and if you somehow calculate the center of gravity, center of thing of this, you will assume that all the charge is constrained at this center, and you will assume this center as a point charge. Understood?
Okay.
Then you can apply, but on the directly a bigger body you can't apply. Okay,
Yes.
so that's the thing. For example, I'll just take another example. Let's say this is a body. You have a charge here, here, in a random way. Okay. Let's say this side is empty. So you don't know what is the center of mass of this particle. So you have to calculate for each of the particle, considering. Okay, you can't directly do that this and another body similar like this, and you can't do Q1 into Q2. Okay, you have to take individual distances also. But if I give you another case, for example, this is a proper circle. Let's say have a proper circle. Assume it to be a proper circle, okay? And you have a charge all around in a properly distributed way. So in this case, the center of the charge will come out to be the center, right? At the very center,
Okay.
right? The concentration, because na, what
Uh-huh.
happens when a proper circular body is there. What is the center of mass? All this mass is spread over the body. Still, we assume, right? We have calculated that things in 11 that it is concentrated
Yes.
at the center, right? Same
Yes.
goes
Yes.
with the charge also. Okay. So here you will assume it is concentrated at the start, and you don't have to again calculate for the individual part. You can directly put it from the center. So understood when we have to assume it to be the centered, and when you can apply the Coulomb's law.
Yes, sir.
Okay. Yeah. Coulomb's point charge. And the next thing is okay. Yeah. Oh yeah. Okay. Look, this thing I'm not going to write. Coulomb's law is very similar to Newton's gravitational law. Just
Yes.
one difference is there. Coulomb's law of, like, this force can be a negative also. Like, basically, this force can be attractive. This force can be repulsive. But in case
Yes.
of
Yes.
your Newton's law, that is only applicable for, like, that is only a attractive force. Like, there is no repulsion in those cases. So
Yes,
you
sir.
have to, okay, these things are there. It also obeys Newton's third law. Coulomb's law obeys Newton's third law. What is Newton's third law?
For every action, there is an equal and opposite reaction.
Obeys Newton's third law. Yeah. So that is it obeys Newton's third law. How it obeys? If two normal bodies are there, Q1 and Q2, these both charges apply equal and opposite forces to each other, right?
Yes.
And this is what Newton's third law says. If this
Acha.
Q1 is applying F force on Q2 towards himself, F1. Okay, basically F1 on 2 mean to say force on. Okay, let's rewrite in a different. Force on 2 due to 1, right? So it will be equals to by a magnitude, not by a direction. Direction will be opposite. Okay, yeah, 1 2 force on 1, like this charge will provide force on 1 due to 2. It will also be equals to this. If you see the direction, the forces have a different direction, right?
Yes.
but the magnitude is same. Okay,
Uh,
so that's if, whether it is attractive, whether it's repulsive. You don't have to go with the direction, but yeah, the magnitude will still be the same. Okay, so that's the thing.
yes.
Okay, so okay, you know what is conservative force and non-conservative force?
Conservative is it cannot be destroyed. Force, the force cannot be created, cannot be destroyed.
Okay, and what about the
It
non-conservative
just
force?
I don't know.
Okay, what do you think? This comes under conservative or not?
What?
Like this Coulomb's law thing, whatever we have studied, does it comes under conservative forces? Look, first of all, what is conservative? I'll just explain in a minute. The conservative forces are the forces which follows the conservation of energy. Okay, which follows the
Okay.
conservation of energy. But the forces who don't uh, obey the conservation of energy are non-conservative force. Just I'll give an example. For example, you are here, okay? You are at this level. Let's say we call it as a zero level, right? If I'm saying I am at the zero level, what is my potential energy? I
Zero.
can say mg h as
Acha,
zero.
yes, 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 yes.
So I can say zero, right? Let's say somehow I did some work and put this object to here. What at some height h. What is my energy now? Mgh is equal.
NGH.
Okay. So let's forget this thing. You know it is here, right? If this object,
Yes.
I'll just drop it from here. It will come down. Here its potential energy will go to zero, but it will be converted into your mv square, right?
Kinetic
The
energy.
kinetic energy. Okay. But let's take another thing. For example, okay, so you can see the energy is conserved, right? Energy is conserved, just the form has been changed. Is it?
Yes.
Body is still having energy. Let's take another
Yes, yes.
example of a frictional force. Okay. Uh, if you are here, if you are going in a this direction, what is the direction of frictional force? It will be in this direction, right?
Yes.
Let's say you move some distance k, so and assume h of the energy have been lost. Okay, but if
Uh-huh.
what is the case? If you move back, will you get this energy again?
No,
No, right? Because if you
it's
see
already
carefully,
been
when you,
dissipated.
yeah, it even another h will get dissipate, right? Here you have
Yes.
lost h. Here when you reach here, you will be losing 2h of energy, right?
Mm.
So
Yes,
that's
sir.
why this comes under non-conservative force.
Okay, sir.
Understood my point? You started from this
Um,
position. You had, let's say, 2h energy you had. You reached this position. How much energy you are left with h? So what you will assume, when you come back to this position, you will be getting 2h. No, but when you move here, you will get 0 energy. But here it is
okay.
not the case. Okay, let's say you had some velocity, half mv square here, and you are moving upside. You will move until this half mv square comes to 0, and it will convert it as mgh, some height, let's say. But when you come back to this position, this thing will come as 0, height will be 0, but you will again get your energy as half mv square. Understood?
Yes.
Okay.
Yes,
You
sir.
don't have to tell different factors are here. No. At the end of the day, we are talking about the
Uh-huh.
particular force. Here, this frictional force, the what we are talking about, is frictional force. It is not a conservative, right? It is changing its direction.
No.
But here,
Yes.
this gravitational force was a conservative force. So here also same applies in the electrostatic. Is it clear?
Yes, sir.
Okay. Okay. Till now, if you have any doubt, let me know.
No, sir. All's clear.
Everything is clear, right?
Yes.
Okay. Pratham, like to. Okay, I think 50, right? 30 minutes is left. 20 minutes left, right?
Yes.
Okay. So let me check. Let's start with the problem. Okay, let's do one more thing. Yeah, I can rewrite this thing. Electrostatic is a conservative.
Conservative.
So look, till now we have discussed or covered the Coulomb's law in a scalar form.
Okay.
Okay. Let's move to the vector form today itself. Coulomb's law in vector form. Look, the both thing are same. Just we'll be using some vectors. Okay. Yeah. Now what I'm going to say is, let's say this is some center point. Okay. With respect to this, in coordinate plane we have center. From there we assume the points. Let's say this is my center point. Okay.
Okay.
Do I have anything? No, I don't have. Okay. All right. So what I'm going to say, let's say this is particle Q1, this is particle Q. Okay. In some coordinate plane, this particle is at some position vector R1. This particle is at some position vector R2. Okay.
Okay.
RQ2. So it is at some position vector R2. Is it clear?
Hmm.
So what is the
Yes.
distance between Q1 and Q2?
R1 square plus R2 square plus 2 R1 R2 cos theta.
Yeah. Okay. So look, we will just write in the vector form. The what you have told, you have given me the result in the magnitude value, right?
Yes.
So yeah, let's write in the vector form. So if I write in the vector form, let's say in vector form, we don't we need the direction also. Let's say I'm talking about this direction. So what is my value? What will be my r vector? Let's say this is my r vector. Okay, mean r1, r2, this r vector. What is this r vector? It is nothing but r2 vector, position vector minus r1 vector. Understood?
Yes. Yes.
Okay, that's fine. All right. Let's say, okay. Now what I'm writing is I'm writing force on one due to two. What I'm going to write is
Okay.
I'm going to write what is the force on one due to two.
2.
Understood?
Yes. Sir, I can't hear you. Your voice is not like I can't even hear your voice at all. It's something else. It's like air coming through your microphone.
Hello, Pratham. Is it audible?
Yes, yes, sir. Now you are.
Okay. Yeah. So what I was saying, look, this is the first condition. Okay. Let's merge both of them instead of taking two different conditions. Okay. I'll be making two forces. This force is force on two due to one. Okay.
Okay.
And this is a force on one due to two. Clear?
Okay.
So if I'm talking about force on 2 due to 1, I'll be taking this vector, right? Because I am going in this
Yes.
direction. If I'm talking about this, like if force on 1 due to 2, so I'll be taking another vector which is in this direction.
Yes.
Okay. So instead of this, can I write this vector as r as what I can write it as 2 1 towards 2 from 1. Here I can write as
Okay.
towards 1 due to 2, right?
Yeah. Yes.
This, look, one more thing, this r21 and this r12, this thing can vary in ncrt and different word. It's up to you how you assume. Okay,
Okay.
some books will say that f12 means you are going on 1 from 2. Some books will say no, you are going on 2 from 1. Okay, this is what they can
Yes.
say. So yeah, it's up to you which understanding you are going with. Okay, so don't get confused in between these two things. And in some books also different thing is there. For force, what they say one on due to two, and in case of R they say what they say one to two. Or understood? They change this condition. For this they use
Acha.
this abbreviation. For this they use this abbreviation.
Okay.
So you have to think of it in your way. I'll say just take, if you are solving a problem, don't change this thing for R and F. Okay, if you are choosing one on one due to two, Here also put 1 on due to 2. Okay, don't change this thing in R and F. Okay, that's
Yes.
the thing. All right. So yeah, but this is the force vector. Okay, I know this thing. What is the what should be the formula? It should come out as K Q1 and Q2 divided by what is the distance. So I'm not sure what is it. I'll just write the magnitude for now. Okay. So I'm going on 1 due to 2. So I'll be writing as R1 2 the magnitude square. Clear?
Yes.
I also have to give the direction. So what is the direction? Again, it's very simple. 1 due to 2. So R, I will put a unit vector. Understood?
Yes, sir.
Okay. Now you also know one thing that R vector, if I have to write this R vector, what is it? It is nothing but R12 magnitude times of R12 unit vector, right? So can I
Yes,
say
sir.
R12 unit vector is nothing but your R12 vector divided by R12 magnitude. So if you just substitute this
Yes.
value, what you are going to get? You will get this Q1 Q2 divided by R12 the magnitude cube times of R vector.
Yes.
Okay. So these two formula you can
Mm.
look. You just have to remember one. You can convert one from another. Okay. Or better, no,
Okay.
don't remember this part. What you can remember is, you know a simple formula. What is the simple formula? F equals to K Q1 Q2 divided by R. But you know, if I am working in the vector environment, what I can do is I can just put a unit vector to show the direction. But if you resolve this, you will get this part itself. Understood? This is how you can think
Yes.
of the problem. Okay. Instead of just learning this. All right. So we
Okay.
did this part. Let's remove it. Okay. What is the value of R12? Let's explain that part also. R, it is nothing but your R1 vector minus R2 vector, right? So we can put it as K Q1 Q2 divided by your R1 minus R2 vector, the magnitude of it cube, and here it will come out as, yeah, here it will come out as R1 this minus R2 this. Understood?
Okay. Yes.
Yeah. Yeah. Any confusion in between?
No.
Right. So do I have to again like do the complete thing for F21, or I can just reverse this two and one thing,
Reverse.
right? I can just reverse them. Okay. So for F, let's make it with the red color. F21. It is nothing but with K Q1 Q2, and this is the same thing, so I don't have to change it. What I'll do, 2 minus this, right? Also, you know one
Yes.
thing, that magnitude will be same, right? Whether I'm going this way, whether I'm saying this way, the both thing are same, because the
Yes,
magnitude
sir.
magnitude only knows the value. It don't know the direction, right?
Yes, sir.
So can I say one? Okay, if you observe one thing, if I take minus the negative common, what I am going to get?
Okay, the negative, the opposite.
R1 minus R. Can I get this?
Yes.
And this will still remain the same, right? Okay,
Yes.
what you can observe, can you see this thing? uh, let's take this. These two things are same. You
But the
can observe
denominator
one
is not
difference.
same.
Yeah, no, that's what I explained a bit. This is a magnitude, right?
Yes, yes.
Okay,
But
and
the
I just told you
direction.
this thing. Yeah, look, just a second, I'll tell you. What is this thing? This magnitude. This is nothing but R1 2 magnitude, right?
Yes, yes. I got that, but you were saying that they both are same. So I was just saying the direction is not same.
Yeah, okay, yeah. But look, I just wanted to explain this part. Okay, so you know this is a. Okay, let's remove your query also. You know this is a magnitude, so we can directly replace this thing with the another R,
Okay.
K Q1, which is actual distance, basically the R square. You know. Okay, and here you will be
Uh-huh.
having a the vector form. Understood? Now is it clear? If I write
R
this in the
cube.
same manner, Yeah, if I write
Sorry,
this one in the same manner, yeah, okay. Any doubt?
you have written R square. It should be R cube.
Okay, yeah, okay, sorry. Put it back to
Yeah. Okay.
R2. So here you will be getting k q1 q2 divided by r cube
Yes.
r1 minus r2. Okay, and I
Okay.
think we should not do this directly. I can write this here that r12 magnitude is equals to r21 magnitude equals to r. Okay, now this thing can
Yes.
be justified. All right. Now you can see the equation seems same. So finally, I can say that your f21 is equals to negative of f12. Understood?
Yes, sir.
What is this? This is basically force on 2 due to 1. This is basically the
And
force applied on 1 due to 2. Let's forget the object is same. So can I say this is the force applied by the 1? This is the force applied by the 2. If I remove
yes.
this negative sign, if I just put the magnitude again, can I say f21 magnitude equals to f12 magnitude?
Okay.
And you can see this is nothing but one thing we get from the Newton's third law,
Yes, sir.
right? Force applied by one object on another, both are same. But this direction is different. You can check this direction using this negative parameter.
Yes, sir.
Got it? Any doubt?
No, sir.
Okay. In yesterday, did you solve any problem on the basis of the topic we discussed earlier?
Uh, did some in rough some illustrations in my Allen book.
Okay. Any doubt in those?
No, they were easy.
No, right?
I could do them.
All right. Look, one thing. What I'm saying is, na, after the class, try to do this derivation by yourself. Although it's an easy thing, just a vector confusion might be there. Okay, so you should not get confused in these things because
Okay.
what
Yeah.
happens might be the question will give you generally. Okay, is there any lag in my voice?
No.
Okay. Yeah. So what I'm saying is, look, generally what will happen, you'll be getting the magnitude properly. But what happens sometimes the question is on the vector form. It won't give you the distance between them. It will directly give the position of the particle. In those cases, you might have to follow this vector rule. Okay. So then and there you don't have to get confused with this. Is it
Okay.
clear?
Yes, sir.
All right. So after this, we are left to go with the superposition principle. Okay. So I'll just take the
Yes.
superposition principle in a one go. Superposition principle. What it says. Okay. But basically, what it does is it help us to calculate the force on a charge due to two or more than charge. Okay, due
Okay.
to more than one charge. It provides us the way to calculate force on a charge due to one or more charge. If one charge is there, you don't have to do anything. You even don't have to think of superposition principle. But if one more than one charge is there, then you have to think of it. Okay. How you have to think of it? One charge is there. This. Okay. Call it Q. Now you have too many
Okay.
charges. Let's say this charge Q1, this charge Q2, another charge Q3. Okay. Another charge here you have as Q4. Everyone have a
Okay.
different distance also. Let's say this the position vector of this, if you say not, okay, for other we'll use what I can say r1 r2 and r3, you can say that. Okay,
Okay.
so in a similar fashion, let's say q5. These many things are there. Let's say the interaction between them is going in this direction. Okay, this is putting in this direction. This is providing force in this direction. Okay, so these many
Okay.
interactions are there. How you'll be solving this thing? We have a superposition principle. What it says, just take the sum, like just sum of the all the forces on that particular particle. Okay, what it meant?
Okay.
Let's calculate the F net. F net.
So it's basically Q1 plus
What?
Q2 plus Q3 into Q.
This is Q1, Q2, Q3, Q4, the Q5. Okay.
And Q5, yes.
Yeah. Okay. Just remove this force. Yeah. So what is your F net? Simple. I am working on this particle, right?
Yes.
So force on Q naught, basically Q naught due to 2, force on Q naught due to 1. So on, what you will do, force on Q naught due to 5. This is what you have to calculate. That's it. You don't have to go for more than this. You have to just do this thing. If more than 5
Okay.
particles, let's say 100 particles, the same thing you have to do. If you put the formula, look here it is good to go with the vector form. So what is the formula? Uh, Make it black. Yeah. So what is the that? K Q naught Q2 divided by. Now let's put the vector thing. Understood this thing?
Yes.
Same you can do it for the every particle. R 0, 1 of 9 and so on. Okay. So I can, if you see carefully, I have two things as a common. These two things, right? Can you see, like I'll be having these two things common in all cases. If I write even this part, I'll be having this as a common thing. So I can rewrite this thing as this, and you will be having 0, 5 of this, right? Can you observe this part? Hello, Pratham. Yeah, hello. Am I audible?
Uh,
Hello,
Hello?
hello. Here, Pratham.
Oh, yeah, sir, I was muted, sorry. I
Okay,
was
okay,
speaking.
okay. Yeah. So, like, can you observe this? Like, K and Q naught will be common in all the cases.
Hanji.
Right? So I can
Okay.
just take this as common instead of writing this thing again. So you can see what I'm left with, the thing, the charge itself,
Yes, sir.
right, and the distance.
Hmm.
Okay? Instead of writing, I'll just put the dot dot, and it will be for the final one.
Yes, sir.
Naught divided by R naught 5. Okay, one thing I should have done is, instead of this two part, let's put the first one here as the first one. Okay, so it won't be
Okay.
confusing that we are starting with the second person. We are
Yeah.
starting with the one. Basically, you just have to cover all the particle. That's it.
Yes, sir.
Apart from that particle itself. Okay. So this is what the
Okay.
superposition principle was. A very simple idea. Okay.
Yes, sir.
Now the thing is, if you are applying a Coulomb's law and the principle of superposition, okay, you will be able to solve all the problems. Okay. So
Okay.
one question is there. Hmm, I think we should do it today itself or in the next class. Only confusion I have. Okay. Can you figure out the? Okay, just assume a particle is there.
Okay.
Okay, just a second. Okay, yeah. So the question is, a particle is revolving around a circle.
Okay.
The circle, okay, a particle of charge. Okay, let's take the charge of this particle as plus q. Okay, plus q1 around a circle. and around around yeah around another charge of mass. Let's not keep the mass charge q2. Okay, with the velocity, you can figure out the velocity by yourself, I think. At some distance, some r. Okay, at some distance r. This is charge q1. This is charge q2. This particle has mass m. Okay, this is what you have given. You just have to calculate the velocity of the particle and angular frequency if you can. These two things you have to give. Or okay, one more thing: the time period. Can you figure out all these three things? Any idea if you are having?
I'll try.
Okay, yeah, you can try. That's fine. Time period. Okay. Yeah. Before going to that, you know what is velocity, right? You know what is angular frequency,
Yes,
right? You can rewrite
11th
it
yes,
as angular speed. Okay, angular speed,
yes, yes.
and the time period is there. Okay. So what I'm saying is try to solve these problem and look in the next class. Oh yeah. One more thing. If you have any book, you will find too many questions based on your that part, the Coulomb's law. Okay. So try as much as problem if you can. After this, try to solve this problem. Understood?
Okay.
So this is what you have to do. Yeah. So
To solve the Coulomb law. Coulomb's
yeah,
law.
it is also based on the Coulomb's law itself. Uh,
Okay.
okay. It's
So
based on the
what all is
Coulomb's
the
law. That's why
homework?
I have not given the mass for this particle. They don't apply gravitational force between two particles. Okay, just remove. Hinting is you. I am giving you hint. Particle is there. Another particle is there. It is revolving around. You know, if particle is revolving around, you need a centripetal force, right?
Yes, yes, yes.
Okay. So this Coulomb's law is nothing
So
but the
first
centripetal
in
force. Okay.
the
Yeah.
first one
So
we'll
now
just
you just
equate it
have
with the
to play
centripetal
with the
force
yeah. You just have to play with
and
the
find the
equation and you
V.
will get the answer. Yeah,
Yes,
exactly. The find the
I
v.
got the
If you
formula.
find the v, you will okay. If you find the angular frequency, you will directly like if any of these two you find, you will get both of them. Okay, you just have to
Yeah,
change the
I got
equation.
all of them.
Okay, that's fine. Okay. So yeah, so that's all for the today.
Okay.
Okay. So any doubt you have?
So what's no sir.
It's 7:50, right?
Um,
No, you
let
are
me check.
asking something. Huh?
Yeah. Uh, what all is my homework? I
What
have
are?
to do one derivation and what else is my homework?
No, no, yeah, derivation is what I'm saying is, look, first what you have to do, revise this part, Coulomb's law, okay? Practice this part,
Yes, yeah, yeah.
okay? Like normal thing, I am not saying you to again just go with the Coulomb's law in a normal form, okay? If you can go, just revise these formula, these units, these values are important, okay? Revise if you have any theoretical book, read those part, okay? Take the difference between the
Okay.
permittivity and free space and a medium. Don't take much time on that. Directly go to the vector form. Just do a simple derivation. Even if you do it by seeing the derivation, I just want to
Okay.
you to clear with one and two thing, right? Because what happens in some book it is written one to two. It says that
Yes, yes.
from you are going from one to two. Some book they write this thing. It says you are going from two to one. Some book does the both thing, but they do this for f, this for r, or vice versa. You what I'm saying is you don't have to do. If you are doing this thing, if you are assuming this, assume it for f and r both. If you are assuming this thing, assume it for both.
Uh,
Understood what I'm trying to say?
okay. Yes,
Okay,
yes.
after if yeah, okay,
Got it.
got it right. If you do this, after this, what you have to do, solve some problem based on it. A very basic problem will be there, like the two charges will be there. You might have to calculate the force between them. Two charges, force is given, you have to calculate r. Just solve these kind of forces, questions three or four. Okay, why I'm saying three or four? Because of the calculation thing. Now you are into the charge, you'll be playing with the powers. Okay,
Yes.
you will be playing with the negative powers, positive power. You have to understand the difference between two charges when one is negative, one is positive. If you see all the derivations, I have taken both as q1 and q2. I didn't tell which is positive or negative. Seems goes different. For example, if both particles are positive, the force will be like this. If one is positive, one is negative, the thing will go like this. Okay, one will go attractive, one will go repulsive. These things are going to happen. Okay, so this is what you have to
Okay.
understand. If you solve 3 to 4 problems based on it, then you can come up with this part. Okay, if you think you can directly
Okay.
do, it's up to you, you can try. Okay, so yeah,
Okay.
understood the task.
Yes, sir.
Okay, so yeah. Also, if it will better if you along with take a small revision of the previous things we have discussed. Okay,
Okay, sir.
so yeah, that's all for the today's class.
Okay. Thank you,
You
sir.
can leave.
Bye,
Okay,
sir.
yeah, goodbye. Goodbye. I'll just send this.